This is Math 7, Section 1.4, Introducing the Real Number System. Let's start with extend the concept of absolute values to all irrational numbers. If you can remember, irrational numbers means that it cannot be written as m over n, where n does not equal 0. That's an irrational number. So let's extend the concept of absolute values to irrational numbers. We've learned a lot with rational numbers. Here, take an irrational number, for example, negative square root of 15. Let's find the absolute value of that, and it would equal the absolute value of just the square root of 15, not with the negative. Remember, the negative cannot go inside or it will be imaginary. We're just doing irrational, so it is on the outside here. Now, because these are equal, their distance on a number line is going to be equal from 0. So if one extends this far, the other one extends this far, because one is negative in here, the other is positive. These two distances are equal. This is just the distance to negative square root of 15. This is the distance to the square root of 15. But these are both the square root of 15 units. Because you could say both of these are equal to the square root of 15. The absolute value of this is equal to square root of 15, absolute value of that is equal to square root of 15. Further units are the same, but they're in opposite directions on the number line, equidistant. So this is how you would approximate it. This is how you would say their distance, but if we're going to approximate it, use a calculator to find that this equals about 3.87. So this distance will be about 3.87. So if we have 1, 2, 3 here, and 4 down there, that's about where it would be. 1, 2, 3, negative 4, negative 3, negative 2, negative 1. And it falls in between the negative 3 and the negative 4, and of the 3 and the 4 on this side. Now let's do the next section, decimal forms of irrational numbers. You have seen that rational numbers can be written as terminating or repeating decimals. It can be shown algebraically that every repeating decimal is also a rational number. All non-terminating and non-repeating decimals are irrational. So if we wrote 1.3 repeating, we know that this is equal to a rational number because it's repeating. And in fact, it is equal to 1 1/3 or 4/3. This is rational. But irrational would be if it's like 3.5910637 ... and it's not repeating at all. That would be irrational. So therefore, it cannot be written in an mn form. The square root of 2 is irrational. Pi, irrational. We know that pi is 3.1415926.5. These are just examples. Now let's introduce the real number system and the real number line. If you've been listening closely, you would have heard me mention imaginary numbers in a couple of lessons. When we say imaginary, that means they're not real. Like imaginary friends are not real. So these are all real. We're only talking about the real system here. We have not moved on to imaginary numbers yet. You have seen that the number line is made up of rational and irrational numbers. They're both real. So when we talk about real numbers, not imaginary, they are real. But we have two kinds. We have rational numbers. Remember, we can write them as n over n, where n does not equal 0. And we have irrational numbers. They cannot be written as m over n. Cannot be. Then between our rational numbers, there's two ways that we can divide them. We can have integers, which are our whole numbers, things you see on the number line, from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. All of these will be our integers. But they can be written in the mn form, but there are other ones that cannot be written in mn form, that can be written in mn form but are not a whole number, and those are called non-integers. Sorry, you couldn't see those. Here, now you can see them. Let me repeat that. So real numbers are not imaginary. Rational numbers can be written as m over n, where n does not equal 0. Irrational numbers cannot be written as m over n. Integers are all these whole numbers. And non-integers are things like terminating or repeated decimals. Remember, non-terminating or non-repeating decimals will go up here with irrational numbers. Now let's talk about integers. There's a couple kinds. We have, negative integers, things like -5, -4, -3, -2, -1. And then we have whole numbers. These whole numbers can be divided into 0, which is just 0, and positive integers. Things like 1, 2, 3, 4, and 5. So over here, for our terminating and repeating decimals, we can have fractions like 1/3, or we can have 0.56 repeating. These would be examples of non-integers. Integers can be written as whole numbers, negative or positive or 0. And this is kind of how we organize our numbers. I need a new piece of paper. 1 second. Okay, let's move on to the next little section where we order real numbers on the number line. Real numbers appear in many forms, such as fractions, negative decimals, irrational numbers. When placing real numbers on the number line, it is easiest to compare and place them using their decimal forms. So we're going to convert everything we get into a decimal form. It's just easier that way. Let's do example 11. If there's a little calculator symbol, that means you can use your calculator. So on A, we can use our calculator. Let's represent each real number in decimal form with 3 decimal places. We're starting with 5 and 11 over 13. Put that into the calculator. All you have to do is put in 11 divided by 13 to get 0.846. And when you divide this in the calculator, this is what you get. And we already know that there's a 5 at the beginning. So when you see a mixed number, put the 5 to start, and then put just the fraction in the calculator. It's just easier that way. Let's do the next one, square root of 30. You can type this into your calculator. Estimating the 3 digits, it's 5.477. Negative 84 over 25 is negative 3.360. Calculator will tell you that. The next one it already gives us as decimal, negative 8.283, with the 8.3 only repeating. And that would be estimated because after 8.3, if you write out long ways, it would be 8.2838383, We want to estimate 3 decimal places. Therefore, we estimate this one to here. Since it's larger than 5, we estimate up, and you get negative 8.284. That might be confusing how we got there, but if we're not writing it as a repeating decimal, we have to round. So you have to look at what's after it to see if you round up or down. And we had to round up. Next one is pi squared equals about 9.870. Notice each of these have 3 decimal places. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That is that. Now B says order the real numbers from least to greatest. Smallest is going to be this big negative number here, negative 8.284. After that's going to be the next negative number, negative 3.360. So we've done that one, Next one is going to be this 5.477. Next one's going to be the other 5.846. Next one is going to be the pi squared, 9.870. We're going to put in their original forms, which gives us negative 8.283, repeating, negative 84 over 25, square root of 30, 5 and 11/13, and pi squared. C, locate each real number approximately on the real number line. Draw a real number line. The smallest we go down to is negative 8, so I'm going to make a negative 9 on here. The biggest we go up to is 9.8, so I'm going to make a 10 because we're going up from 10. So all these numbers will be in this range. The 0, about in the middle, a little bit closer to the 9, and then I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's our 10. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7, negative 8. And 0. Now we can graph these. The negative 8.284, you can see it's between, we go all the way to negative 8, and then you go about 0.28 more. So if this is divided into about 10 spaces, you go about 2 plus a little extra. And so that right there, I'm just going to draw an arrow. Negative 3.360, we go all the way to negative 3, and then we go about another third of the line here. And that's where you'll find this one. 5.477, we go all the way to the 5, and then we have to go a little bit more. It's 0.4, so we go about 4 spaces, and then a little more because it's 7. We're just approximating here. 5.84 is a little bit farther in there, but it's still the same general area. And then 9.87, we go all the way to 9, and then to 8/10 of it. It's right about there. And that's how you label them on the number line. Go ahead and try guided practice. 1, 2, 3, and 4, and we'll see you in class.